Yep. Okay. Hello. Hello. Okay, it's working. So thanks everyone for joining today. So my name is Fan Lo. So I'm a security architect in the application network and security division at Broadcom. So quickly introduce myself. I joined the company about 1.5 years ago, and prior to Broadcom, I spent about 15 years in security operations, building and running a global SOC. So today I want to talk to you from a practitioner's point of view about zero trust. And if you do have any questions, I'll be at the booth section after this session, so feel free to reach out to me if you have any questions. So I assume you guys are familiar with zero trust, so I'm not going to bore you with this slide. But overall, zero trust is not a single architecture. There's no architecture diagram to tell you this is how zero trust looks like, but a set of guiding principles of workflows, system design, and operations that can be used to improve your security posture, to limit the attack surface, to stop the attacker moving laterally within your environment. And I will give you a little bit of high-level demo what these principles are in a few minutes. So these are the 5 focus areas of zero trust. Users, like MFA, having a strong MFA, privileged users access control management platform, policies, and so on. I can talk about users for hours, but that's not for today. But I'm going to talk about devices, networks, especially microsegmentations, through distributed firewall, a little bit of workloads, and how you can protect the applications within your VCF infrastructure. And overall, how can we provide you that high-level visibility of what's happening in your network? So our vDefend solutions is a multi-layer defense in-depth solution that protects and enables zero trust in your VCF infrastructure. So starting off with the internet traffic, perimeter firewall, then you can see a bunch of technologies here. Gateway firewall, layer 7 gateway firewall, distributed firewalls to achieve segmentations and micro-segmentations, ATP solutions for deep packet inspections, malware prevention or ransomware protection, and then web application firewall, which is our AV solution. So what we want to do is to deploy these solutions as close to the workload as possible. Then sitting on top is the security intelligence. I will talk about security intelligence in a bit more detail in the next slide. So this is the building blocks of vDefend solutions. What we recently introduced is something called the security assessment, which is sitting at the very bottom here. The VCF infrastructure and workloads security assessment. So what we tend to do is to assess how your VCF infrastructure is configured. So if you look on the internet or news, you can see some organizations, their ESXi or hypervisor got compromised by ransomware attackers, where the attacker encrypted the VMDKs, and it was really hard to recover from a ransomware attack. So making sure your VCF infrastructure is configured properly, vSphere, ESXi, vSAN, virtual machines, SDDC manager, and NSX manager, I call it, is to create a strong foundation. So this security assessment focuses on the infrastructure of the technical configurations, but also assess how your security maturity levels of all the workloads in the VCF infrastructure. And on top of all of this, we have the distributed firewall sitting in the hypervisor, layer 7 gateway firewall if you want to perform FQDN and filtering, blocking social media websites, for example, and achieve segmentation or micro-segmentation. And of course, if you want to perform deep dive packet inspections or malware prevention or have out-of-the-box use cases to detect abnormalities on your network level, then we have the ATP solution. So if we couple ATP solution with distributed firewall and gateway firewall, then this is the security intelligence that can provide you that comprehensive overview. Because security intelligence, it has multiple use cases. So first is data visualization. So to look at what exactly is going on the network level in the NSX segments. Second is it provides you this layer 7 context that normally firewall doesn't provide you, like app IDs. It provides you rule recommendations based on application IDs, source usernames, process names, or even FQDNs. The other use case of security intelligence is for incident response. And this is a very powerful interface. Say, a security analyst wants to understand or visualize the attack path. You can actually use security intelligence to build that nice diagram to understand how the attacker moved laterally within your environment. And on top of this, this is all AI-powered threat analytics. So we do have a great threat intelligence team sitting in the back end providing real-time threat intelligence information, for example, IDS signatures, WAF signatures, or ATP-related signatures released on an hourly basis. I'm going to spend a bit more time talk about distributed firewall to achieve zero trust today. So journey to zero trust, you start off with the infrastructure. So infrastructure, like a distributed firewall, you normally start with grouping and tagging. So to make sure you have proper grouping of your zones, production environment, dev environment, or other common services. You want to secure your zones. What are the policies you want to create? A can talk to B, B cannot talk to C, for example. Then you want to secure your applications. What kind of applications are allowed? Like, for example, application in the production environment cannot talk to the, applications in the development environment cannot talk to applications in the production environment. There are many, many scenarios you want to limit the attack surface based on applications. But furthermore, you may also want to limit applications talking to each other, even within the same zone, for example, production zone. But last but not least, is where the ATP solution comes in to give you that comprehensive east-west traffic protection across the zones, groups, or applications. And this is a typical journey to achieve zero trust. But again, like I mentioned, this doesn't really cover the user aspects, which is MFA or privileged users access management. That is a complete different topic. So very high level overview, what is DFW? So DFW is a layer 4 to layer 7 statewide firewall with the capability to perform FQDN or URL filtering. It has built-in IDFW, identity firewall. So if you say, I want to have AD user groups built into the firewall, you can do that to provide certain level of access control through the built-in IDFW functions. It supports virtual machines, containers, or even bare metal. The other unique advantages, there's quite a few here, I won't name all of them, but for example, no hairpinning required. All these DFW policies are stored on the NSX manager, which is pushed down to the virtual machine's VNIC. Pushed down to the hypervisor and pushed down to the VNIC of a virtual machine. From a scaling perspective, if you need more compute power, let's say you have hundreds of DFW policies, what all you need to do is to add additional ESXi hosts to give that additional horsepower. And doing vMotion, if you want to move a set of virtual machines from one ESXi host to another, because the rule tables are stored on the virtual machine itself, there will be no impact when you do that vMotion between ESXi hosts of this set of virtual machines. And the protection remains intact. And that is very important to make sure there's no attackers trying to utilize this time window to compromise your environment. So grouping and tagging. So what I normally say, there are 3 steps you need to follow for segmentation. The first is to create a strong foundation, which is grouping and tagging. Second is to create policies and profiles for your environment based on zones, based on infrastructures, based on applications. The third, which is the most important in my opinion, is to test the effectiveness of those profiles and policies you created, which is like for example, you can use Verni, but we also use security intelligence and vDefend security intelligence from a security perspective, but also give you a nice visualization where you can test the effectiveness of those policies you created. So grouping, you, just give me a second, okay. So grouping, there are different ways to group virtual machine, create grouping based on virtual machines, based on operating systems, IP addresses, or if you want to utilize user identity firewall, then you group by AD groups, user groups. So there are multiple scenarios. We provide that flexibility. But in reality, or in most common cases, you want to group by virtual machines. But let's say you have 5,000 virtual machines. You're not going to manually add these 5,000 virtual machines into the groups. What you want to utilize is called the tag. So the tag provides this dynamic grouping. So for example, let's say you have a few hundred virtual machines in your production environment, let's say in the app-1 here. So you will say, and with a similar naming convention, you may want to say, I want to create a tag starts with ABC for all these virtual machines in the production environment. So when you create a group, you will say this group criteria starts with a tag name starts with ABC. The other use case is you may want to create tags for virtual machines that can be applied into different groups in order to create different firewall policies. So this is normally the very first step you want to consider to create proper groups and tags. Tags can be based on environment, it can be based on other factors. So it all depends on how you design your grouping and tagging before you start the micro-segmentation journey. So let's have a look at putting all these together in a brownfield data center. So let's say there's a bunch of applications in a data center. There's no segmentation. You don't know what to do. You only have a bunch of applications. They're talking to each other. They're not properly segmented. There's no segmentation at all. Then you also have a bunch of common services in your DMZ zone. Active Directories, NTP servers, DNS servers, so on and so forth. We call it the common or shared services. The approach I normally take is a 2-stage approach: macro segmentation and micro segmentation. And there's actually a third step, is where the ATV solution comes in to provide that end-to-end protection, east-west traffic protection. So macro segmentation normally talks about large chunks: production environment, test environment, common services, PCI, or other zones for compliance reasons or for whatever business reasons. You want to secure traffic between these services, like test environment cannot talk to production environment, cannot talk to compliance zones. So you want to create that high-level policies to limit the attack surface. But you also want to monitor and add exceptions to inter-zones communications. For example, you may want the test environment to be able to reach the NTP servers in the common services zone. Then after that, you think about microsegmentation. So you need to identify your crown jewels. Like I talked about tags and groups earlier. I may want to create a tag and group to say these servers all belong to these virtual machines or servers all belong to the PCI zone. So you create like 1 or 2 tags to specify that. And when you create a distributed firewall rule, you will create a group based on these tags just for PCI. You may also want to ring fence your segmentation policy and monitor traffic. For example, if these policies triggered for microsegmentation, I want to send the alerts or logs out to a SIEM platform or other third-party logging platform for security monitoring or for compliance reasons. In Zero Trust, if you look at the NIST cybersecurity framework, it talks a lot about policy refinement and making sure the policies are up to date. So from a microsegmentation perspective, this is where security intelligence helps you to identify if there are gaps in your policy configurations. You may want to retire certain policies or add new policies between applications as part of microsegmentation. So 2-stage approach. So let's go back to this, that brownfield data center. Like I mentioned, you start off with a macro segmentation. In this simple scenario, I have a production environment, I have a dev environment, and I have common services, AD, DNS, a patch management server, and so on. Grouping and tagging. The second step is from an infrastructure perspective, I want to start with creating some high-level policies as part of macro segmentation. For example, I want ADs can talk to ADs. I want my private subnets with like 10 dot range can reach out to the NTP server in the common services zone. But I also want to start with blocking insecure protocols. For example, SSH v1, SMB v1. SMB v1, I'm still seeing a lot of organizations allowing SMB v1, which is commonly used by the attacker for Eternal Blue as part of ransomware to scan or distribute or exploit vulnerabilities. So unfortunately, this is still happening. So what I normally tell the customers is block SMB v1, don't even think about it. You want to start on the macro segmentation level. It's a no-brainer, for example. Of course, in reality, there's a lot of insecure protocols you want to implement as quickly as possible. Then we're starting slowly to move into micro-segmentations. I want to protect the zones. Like I mentioned earlier, I don't want, in this scenario, the development zone talk to the production zone, but I want these two zones be able to reach the common services zone for DNS, for DNS to AD or NTP or the patch management server. However, I mentioned the 3-stage approach. How can I validate that my policies or rules are effective? And that is not an easy approach in many scenarios. You may or may not have a tool to test that, to validate the effectiveness of those policies or rules. So this is where security intelligence comes in. I'm not going to talk about security intelligence here. You may have seen there's a lot of presentations about security intelligence, but basically it does provide a simple interface where you can specify rule IDs or groups or zones or usernames to visualize if the traffic between the zones, for example, are protected or not. If it's unprotected, it will show red lines. If it's protected, then you should be able to see a green line, or another color means traffic is blocked between these two zones or applications. So security intelligence is a very powerful tool to validate the effectiveness of the policies or rules you created. Then moving to applications. You can see there's different applications in different zones here in this example. I want to make sure, let's say port 1433 SQL Server protocol, I don't want them to talk to each other, these two groups of applications in different zones. I want to allow this bottom right, let's say it's the development zone, have access to the top left one with port 80. It can be a web server. So you think about how applications can talk to each other in different zones or different groups. Again, security intelligence can help you validate that. It's just a few clicks to achieve it. Then when it comes to intra-applications protections, proper microsegmentations. In the top left example, you can see I have 5 virtual machines sitting in the production zones. But I don't want app number 1, web, talking to the database. So you can see there's a red line. I want to block that traffic. And it's easily achievable by DFW. And the reason being is DFW sits in the hypervisor, and it protects all the workloads within the hypervisor, the virtual machines. The other example is I want to say the common services can reach out to other applications. So there's so many different scenarios when you design your microsegmentation journey to look at how applications talk to applications, and if applications sitting in the same zones, how can I achieve that zero trust, which is a very common practice depending on overall how you design your microsegmentation journey. Last but not least, I talk about the third stage. We talk about macrosegmentation, we talk about microsegmentation, and then ATP. So ATP consists of NDR. NDR is network detection and response, which includes malware prevention service sitting on the workloads, virtual machines, the IDPS events for deep packet inspections on the network level, and network traffic analytics to detect anomalies with 14 out-of-box detectors or use cases. So you want to apply ATP on top after you do microsegmentation to make sure all the workloads and infrastructures are protected to have a proper east-west traffic protection. So from a DFW perspective, this may look very familiar. Like DFW logic is left, right, top, down. And this is just a snapshot from the NSX portal. So you have Ethernet category used for L2 policies. I get asked very often, what is emergency category? So there are different use cases, but one common use case is if a customer suffer from ransomware attack or zero-day attack, you may want to create a policy to block that non-attack vector as quickly as possible, or TTP, tactics, techniques, and procedure. That is where that emergency category can be used for, sitting on top of the rest of the categories. I want to create common policies to block insecure protocols, like the previous example, SMB-v1, SSH-v1. I will do that on the infrastructure level, but I will also allow traffic between AD groups talking to each other. I will allow zones talking to the common or shared services assets. like DNS servers, NTP servers, and so on. The environment categories, production, non-production, how do I make sure they can or cannot talk to each other on a zone level? Then application category, like I mentioned, how can I limit the attack surface only by only allowing certain applications talking to each other, or not talking to each other when they sit within the same production zone environment. And last but not least is the default policy, which is the default layer 3 policy in DFW, which is set to any, which is normally you should put at the very bottom in the configuration in NSX. The design consideration, I thought this is very important. Why apply to matters. And unfortunately, I'm still seeing a lot of apply to is set to DFW. When you set the apply to DFW, it means it applies to all the workloads, which is not a good practice if you do that, because it will consume resources on the hypervisor. So in most scenarios, you want to be very specific. For example, this policy, I only want to allow the HR web group policy, web to app group is only applied to the HR web group and the HR app group. I know exactly how I want the policy to be configured. Then I specify, okay, this policy is only applicable to these groups. So this is something that can be missed when you create segmentation policies or rules, or be overlooked. With that, summary. The key takeaways, start with building a strong foundation. Attackers compromise your environment by leveraging vulnerabilities. You want to do proper security assessment based on your technical configurations of the infrastructure, like how your vSphere is configured, because an attacker can only compromise ESXi or hypervisor through vCenter, for example. You want to make sure you have proper assessment of your security maturity levels of all your workloads. Then you think about, how can I do macro segmentation and micro segmentation properly? And then you think about, okay, attacker may utilize legitimate ports, let's say port 53 for data exfiltration. Then what technologies do I have to perform deep packet inspection? This is where IDS or IPS comes in, or even malware controls to look at the artifacts on the workloads. And last but not least, security intelligence to provide you that comprehensive overview of what exactly is happening in your environment on a network level. So that's all I have today. Thank you for your time, and congratulations. This session has been chosen to be part of the rewards program. If you want to take a minute to scan the QR code, and good luck to retrieve your tokens and win some rewards. Thank you.